YouTube, this is the homeschool chemist here with chemical calculations problems, solving for them. And this problem is going to take an example where we are given the volume and density of a product, and we need to go back and find the amount in grams of the reactants. So in this particular problem, we have phenol undergoing complete combustion with oxygen to produce water vapor and carbon dioxide. We are given the amount of milliliters of water produced, and we're also given the density of that water. The first thing we need to do in this problem is to write a balanced chemical equation. So C6H6O plus O2 is going to form H2O plus CO2. I prefer to use the algebraic method. So A, B, C, and D. And now by putting a letter as the balancing coefficient for each species, I am able to write an expression, an algebraic expression for each species. So if I was going to write an algebraic expression for carbon, it would be 6A is equal to D. To do one for hydrogen, it would be 6A is equal to 2C. And for oxygen, it would be 2B plus A is equal to C plus 2D. Now, if I were to go through and set A to 1, because 6A is equal to D, that would mean D is equal to 6. If I set A equal to 1 and 6A is equal to 2C, then C would equal 3. And now with these three, I can solve for B. So if I came down here and set 2B plus A is 1 is equal to C is equal to 3 plus 2 times D, which is 6. Well, over here I have 15, 2B plus 1 minus 1 from each side. So you have 2B is equal to 14, which means B is equal to 7. So then I can come through and with my new balancing coefficients, I can say that 1 phenol, 7 oxygens, 3 waters, and 6 CO2s is going to be a balanced chemical equation. And this algebraic method for balancing chemical equations always works no matter how many species are in any given reaction. So now that we've done that, we are going to want to find out the number of moles of water produced. Because it gave us a volume and a density, we can find the mass. If you recall, the formula for density is equal to mass over volume. Well, in this particular problem, we were given the density and we were given the volume. If we want to find the number of moles of any species, all we need to do is find the mass, and then we can divide by the molar mass to find the number. So if I was going to rewrite this equation, I would write density times volume is equal to mass. And in this problem, we were given a density of 0.994 grams per milliliter times 15.3 milliliters. When you multiply that through, you are left with 15.21 grams. And this is going to be H2O. So now that we found the number of grams of H2O, now we are prepared to find the number of grams of phenol produced. So 15.21 grams of H2O. First thing we need to do is convert to moles of H2O. Well, 1 mole of H2O is equal to 18.02 grams. And we know that by adding up an oxygen plus 2 hydrogens. Now we got to convert from moles of H2O to moles of phenol. So from our balanced chemical reaction, we found out that 7 moles of water was stoichiometry equivalent to 1 mole of phenol. And now we were given the mass of phenol in that problem. So 1 mole of phenol was equal to 94.11 grams. Now we can multiply this through and we'll see that grams of H2O cancels and we're left with moles of H2O. Moles of H2O cancel out and we're left with moles of phenol. Moles of phenol cancel out and we're left with grams of phenol. So our final answer is going to be 26.48 grams of phenol. And that is our answer to this problem. So that is how we went from the milliliters and the density of a product back to the grams of the reactant.